A programming language is a formal constructed language designed to communicate instructions to a machine, particularly a computer. Programming languages can be used to create programs to control the behavior of the machine or to express algorithms. The earliest programming languages preceded the invention of the digital computer and were used to direct the behavior of machines such as Jacquard, looms and player pianos. Thousands of different programming languages have been created, mainly in the computer field, and many more still are being created every year. Many programming languages require computation to be specified in an imperative form, while other languages use other forms of program specification such as the declarative form. The description of a programming language is usually split into the two components of syntax and semantics. Some languages are defined by a specification document, while other languages have a dominant implementation that is treated as a reference. Definitions. A programming language is a notation for writing programs, which are specifications of a computation or algorithm. Some, but not all, authors restrict the term programming language to those languages that can express all possible algorithms. Traits often considered important for what constitutes a programming language include function and target. A computer programming language is a language used to write computer programs, which involve a computer performing some kind of computation or algorithm and possibly control external devices such as printers, disk drives, robots, and so on. For example, PostScript programs are frequently created by another program to control a computer printer or display. More generally, a programming language may describe computation on some, possibly abstract, machine. It is generally accepted that a complete specification for a programming language includes a description, possibly idealized, of the machine or processor for that language. Programming languages differ from natural languages in that natural languages are only used for interaction between people, while programming languages also allow humans to communicate instructions to machines. Abstractions. Programming languages usually contain abstractions for defining and manipulating data structures or controlling the flow of execution. The practical necessity that a programming language support adequate abstractions is expressed by the abstraction principle. This principle is sometimes formulated as recommendation to the programmer to make proper use of such abstractions. Expressive power. The theory of computation classifies languages by the computations they are capable of expressing. All Turing-complete languages can implement the same set of algorithms. ANSI, ISO SQL 92 and Charity are examples of languages that are not Turing-complete, yet often called programming languages. Markup languages like XML, HTML or TROF, which define structured data, are not usually considered programming languages. Programming languages may, however, share the syntax with markup languages if a computational semantics is defined. XSLT, for example, is a Turing-complete XML dialect. Moreover, LaTeX, which is mostly used for structuring documents, also contains a Turing-complete subset. The term computer language is sometimes used interchangeably with programming language. However, the usage of both terms varies among authors, including the exact scope of each. One usage describes programming languages as a subset of computer languages. For instance, markup languages are sometimes referred to as computer languages to emphasize that they are not meant to be used for programming. Another usage regards programming languages as theoretical constructs for programming abstract machines, and computer languages as the subset thereof that runs on physical computers, which have finite hardware resources. John C. Reynolds emphasizes that formal specification languages are just as much programming languages as other languages intended for execution. He also argues that textual and even graphical input formats that affect the behavior of a computer are programming languages, despite the fact they are commonly not Turing-complete, and remarks that ignorance of programming language concepts is the reason for many flaws in input formats. History. Early developments. The first programming languages designed to communicate instructions to a computer were written in the 1950s. An early high-level programming language to be designed for a computer was Plankalkul, developed for the German Z3 by Konrad Zuse between 1943 and 1945. However, it was not implemented until 1998 and 2000. John Mauchly's shortcode, proposed in 1949, was one of the first high-level languages ever developed for an electronic computer. Unlike machine code, shortcode statements represented mathematical expressions in understandable form. However, the program had to be translated into machine code every time it ran, making the process much slower than running the equivalent machine code. At the University of Manchester, Alec Glennie developed autocode in the early 1950s. A programming language, it used a compiler to automatically convert the language into machine code. The first coding compiler was developed in 1952 for the Mark Chapter 1 computer at the University of Manchester and is considered to be the first compiled, high-level programming language. The second autocode was developed for the Mark Chapter 1 by R. A. Brooker in 1954 and was called the Mark Chapter 1 autocode. Brooker also developed an autocode for the Ferranti Mercury in the 1950s in conjunction with the University of Manchester. The version for the EDSAC2 was devised by D. F. Hartley of University of Cambridge Mathematical Laboratory in 1961. Known as EDSAC2 autocode, it was a straight development from Mercury autocode adapted for local circumstances, and was noted for its object code optimization and source language diagnostics, which were advanced for the time. A contemporary but separate thread of development, Atlas autocode, was developed for the University of Manchester Atlas I machine. Another early programming language was devised by Grace Hopper in the US, called Flowmatic. It was developed for the UNIVACI at Remington, ran during the period from 1955 until 1959. Hopper found that business data processing customers were uncomfortable with mathematical notation, and in early 1955, she and her team wrote a specification for an English programming language and implemented a prototype. The Flowmatic compiler became publicly available in early 1958 and was substantially complete in 1959. Flowmatic was a major influence in the design of COBOL, since only it and its direct descendant TIMACO were in actual use at the time. The language Fortran was developed at IBM in the mid-50s, and became the first widely used high-level general-purpose programming language. Refinement. The period from the 1960s to the late 1970s brought the development of the major language paradigms now in use. APL introduced array programming and influenced functional programming. ALGOL refined both structured procedural programming and the discipline of language specification. The revised report on the algorithmic language, ALGOL 60, became a model for how later language specifications were written. Lisp, implemented in 1958, was the first dynamically typed functional programming language. In the 1960s, Simula was the first language designed to support object-oriented programming. In the mid-1970s, Smalltalk followed with the first purely object-oriented language. C was developed between 1969 and 1973 as a system programming language, and remains popular. Prolog, designed in 1972, was the first logic programming language. In 1978, ML built a polymorphic type system on top of Lisp, pioneering statically typed functional programming languages. Each of these languages spawned descendants, and most modern programming languages count at least one of them in their ancestry. The 1960s and 1970s also saw considerable debate over the merits of structured programming. and whether programming languages should be designed to support it. Edgar Dijkstra, in a famous 1968 letter published in the Communications of the ACM, argued that go-to statements should be eliminated from all higher-level programming languages. Consolidation and growth. The 1980s were years of relative consolidation. C++ combined object-oriented and systems programming. The United States government standardized Ada, a systems programming language derived from Pascal and intended for use by defense contractors. In Japan and elsewhere, vast sums were spent investigating so-called fifth-generation languages that incorporated logic programming constructs. The functional languages community moved to standardize ML and Lisp, rather than inventing new paradigms. All of these movements elaborated upon the ideas invented in the previous decade. One important trend in language design for programming large-scale systems during the 1980s was an increased focus on the use of modules, or large-scale organizational units of code. Modula2, Ada, and ML all developed notable module systems in the 1980s, which were often wedded to generic programming constructs. The rapid growth of the Internet in the mid-1990s created opportunities for new languages. Perl, originally a Unix scripting tool first released in 1987, became common in dynamic websites. Java came to be used for server-side programming, and bytecode virtual machines became popular again in commercial settings with their promise of write once, run anywhere. These developments were not fundamentally novel, rather they were refinements to existing languages and paradigms, and largely based on the C family of programming languages. Programming language evolution continues, in both industry and research. Current directions include security and reliability verification, new kinds of modularity, and database integration such as Microsoft's LINQ. The 4GLs are examples of languages which are domain-specific, such as SQL, which manipulates and returns sets of data rather than the scalar values which are canonical to most programming languages. Perl, for example, with its here document, can hold multiple 4 gigaliters programs, as well as multiple JavaScript programs, in part of its own Perl code, and use variable interpolation in the here document to support multi-language programming.